Okay, here we go, Unit 4 review. I'm not going to slow up in a whole lot of places on this because A, well, you should have looked at it a little bit already, and B, you can always pause me if you are in a setting where you have control of the pause button. So for this first part, state whether the functions represent exponential growth or decay. Remember, if that B value is greater than 1, it's going to be growth, unless you have a negative exponent, of course, and it'll be decay if it's between 0 and 1. So all I've got to look at in each of these is the number that's in the parentheses. That is my base value. Wow, lots of growth. Okay, we got one decay here at the end. Now, I didn't put any negative exponents to this part. Doesn't mean there won't be some on the test. I'm just saying. Okay, so for this next, we're going to state the y-intercept, the shift, the domain, and range. Now, if you remember back to when we were doing some growth and decay, we talked about your y-intercept is always going to be what? Unless there's a shift, it's going to be at this value. Now, could I look that up on the calculator and take a peek at it? Sure. Do I need to really? I don't think so. Shifts, I don't see any values up here in the exponent. I don't see any values out here on the end. So in this case, there's none. Now, what I hope, like I said, that you remember some of the things with growth and decay to make this go a little quicker and maybe not have a need for using the calculator. Well, maybe. But if not, remember, I could get my y-intercept from when x equals 0 on here. X equals 0, y equals 2. Okay, I could get it that way. As far as my domain and range go, domain on these growth and decay problems is always negative infinity to infinity. My range, which we spoke about before, and I could even look at here, is my lowest value, which looks like we're approaching 0, up to positive infinity. And again, that's not going to change unless I have an up or a downshift. An up or a downshift. Okay. Let's see on this next one. Up in the exponent, the -1, this is my left and right shifts. This one's going to be right 1. Let's see how much we can get here going. Negative infinity to infinity, while I'm typing this in, I'm hoping maybe that you're noticing a couple of things. One, I put my exponent in parentheses because I want the x and the -1 to be part of that. If I look at this, I'm like, ooh, my y-intercept, I had to pay a little more attention this time. Why is that? There's a shift. Anytime there's a shift, my y-intercept is shifting with it. So I'll let the calculator help me out on that one. And then my range again, notice, even though this one, now we're going growth instead of decay like last time, I'm still bottom to top, 0 to infinity. Only time this changes, up or down shift. Speaking of, what are my shifts here? Left 2. And if there's a number at the end, down 3. There's my up or down shift. Well, what's that mean to me? Well, for my domain and range, I should now be able to figure this out without even putting it in the calculator. Save myself some time. If it was at 0, and I said if there was an up or down shift, that's going to move your range the exact same way. Now, the y-intercept, I don't blame you if you need to do a little bit of work here. So let's clear that out. Again, if you have exponents and you have a plus minus there, please make sure you put the parentheses because I'll guarantee otherwise your graph's not going to turn out right. So I look, I'm like, okay. So my y-intercept is at 0, 1. Okay? That's all you've got here. A little bit of calculator work. And if you need to get the other parts, you can, but as you notice at the size of this, that could end up kind of getting you later. So be careful. Okay? Graphing the function. We're just graphing. I am going to be watching to make sure you're somewhat accurate, though. So don't just put a generic scribble down and think, he won't notice. Yes, I will. And again, no parentheses this time because I just want the x as my exponent. Now, don't just draw a sketch of that. You know better. Okay, find some whole numbers like -2, 7, negative 1, 1, 0, negative 1. And notice that down 2 shift moved my vertical asymptote. I don't have to draw it in, but don't think I'm not going to be watching to make sure your line doesn't go through it. Okay? You don't have to put the other things. Don't worry about them. Okay? I'll let you worry about that a little later in the test. Okay? Here with my logs, again, just remind yourself, you're like, but I don't have to write down the shifts. I get it. But remember, with logs, especially with as new as they are, any right or left shift is going to move my asymptote for those. And again, if you draw in the asymptotes, it keeps you from doing something careless. Now, if at this point, some of you want to use our critical values, like we did before, you could, and I'll pop those up here in a minute as well. Because if you remember before when we spoke about our critical values, 1, 0, and 10, 1. If I know the shifts for these, the right would change my x values, the up would change my y's. So my points would be at 4, 2, and at 13, 3. But remember, and we'll see as we're going down there went 4, 2, there's 13, 3. My graph does not stop here. If you put a dot, I'm marking it wrong. Because we've spoken before about how it just gets so close to the asymptote that we can't see it. That line is going to continue. That curve is going to continue. That's why we don't just copy. All right. Oh, look, for the third straight quiz or test. When looking at the function 105 to the negative x, Deanne thinks it must be growth since the base is greater than 1, which is normally sensible. Is she correct? Absolutely not. Well, why? Because that negative exponent causes it to act as its reciprocal. That would be decay. You could do it this way. Otherwise, I need to see the word reciprocal of the base. In other words, you're telling me I know this number flips over and causes it to be the opposite of what it would think. So again, lots of little detail stuff, but again, a lot of this should look familiar since we've been doing this exact same stuff for like ever now. Explain how to obtain g of x from f of x. What transformations? What shifts? Right, left shift, opposite of what I would think. Right 4. Number on the end, whether it's a log or an exponent, is always my up or down. Up 1. Simplifying the expressions, we have the difference between using inverses or kind of using our exponent where we make some changes. Like here, 5 and log 5, they're inverses. I get x. For the rest of these, what we were typically doing before is saying, oh yeah, so base, exponent, answer. Okay, base, exponent, answer. The little number is always my base. Whatever's on the side of the equals, in this case for all these is x, is my exponent. That's going to be my solution. And sometimes writing these ways makes us think a little more about what we're doing. Now, number 13, we've discussed these several times. My first job here is to figure out 3 to what power is 27? Well, that's 3. But 3 to the x would be 27, but this is 1/3. It's a fraction to a whole number. How do I flip it to make it from 1/3 to 3 over 1? I put a negative exponent on it. Fraction to whole number to fraction, negative exponent. Hey, speak of, I know it's going to be negative. 10 to what power gets me to 100? 2. Those are the type of things you can play with them in the calculator too. See how they work. 5 to what power gives me the same number back? 1. Sorry guys, no 0 on this one for you. 2 to what power is 1024? Now again, if you don't know, and this isn't one I probably would expect most of you to know, start playing around. Oh, what about 8? Too small. 9. Nope. How about 10? Hey, winner. 10, and get that set. Rewriting into either logarithmic or exponential. We talked before about changing this up a little bit and saying, okay, I've got my base, my power, and my answer, and the log works the same way. My base, my power, my answer. So if I have a feel of this, I can look and say, okay, and maybe this one's easier to do first. Most of you are good at this because it's kind of like these were. Base, exponent, answer. And by doing this, now maybe I can compare these two. I can say, okay, well, I know I'm going to have log somewhere in here. The 2 is my base. Okay, my base here is 5, so I'll do that. My exponent's over here, okay. Exponent's over, oh, my exponent, Hardy, exponent. And then my solution is the part that's in there. And I'm good to go. That's all I'm doing. You've got to get the pattern down on one of them, then you can use that to help you. Expand. Remember, multiply turns into add. Divide turns into subtract. And exponents become coefficients. And again, these are all things you've had in your notes and other things that we've gone over. So here, 3 times x, which means I'm going to have an addition. Yes, you have to put the log with each one. You can't just put log base 2 of 3 plus x. No, they have to be separated. Okay? And that's all I got to do, though. Here with this one, I have the natural log of 10. I'm multiplying, so plus the natural log of x. That would take care of my numerator. And then subtraction for my divide minus my denominator. Now normally, and it's probably a safer idea to do, if you want things to be kept together, like I want these to be kept in the numerator, it's usually better to put parentheses around them, just to make sure. And then our big one, now I'm going to do this one in pieces. I see that that's going to be add since I'm multiplying. Okay, I'm going to group those together. I'm minusing, and I'll deal with that other part here in a minute. So I took care of this multiply and this fraction. You're like, well, there's still a multiply there. I know. Then here, I need to bring those exponents back around. And some of you may, again, have already mentioned here, that's a multiply, so I need to separate those with a plus. Kind of a tight squeeze in there. Now, some of you may be saying, if I forget the parentheses, is that going to be a bad thing? Well, on the front part, you may be able to get away to, but on this part, it is necessary, because if I don't have them, the minus would only be on this part. So I'd have this over 4, and then the y would be out here somewhere, and that's not what I want. So again, if they're together in the numerator or denominator, put them together, group them together with the parentheses. Condensing, oops, let me get that out of the way. Condensing, we're just basically going backwards here. If I have a coefficient, it's going to turn back into an exponent. If I'm subtracting, it becomes division, left to right. That's how I figure out the x to the 7th is on top and the y is on the bottom. Oops. But I always want to deal with those coefficients first. Addition turns back into multiplication. That's as far as I can go. So again, you still have to have a general feel for how all of this works to be able to pace it off pretty decently as you're doing these. Now here, I always would say simplify on this. I haven't marked off on quizzes if you haven't, so I won't start now. But here, I know this is 3, because 9 to the 1/2 is the square root of 9. I'll even do that. 4 to the 3rd power is 64. And now I just go left to right. 3 times 64. So I have log 3 times 64. And the minus becomes divide. And some of you have said, do I need to get it to here? Or even if that goes further, you know, if that simplifies more, do I need to go to log 24? I'm perfectly happy with anything in here. I'd kind of prefer, I'd kind of prefer the 192 over 8 or the 24. But again, as long as you're showing me you understand the condensing portion, I'm good with that. Inverses. Solve for y once you switch x and y. In order to do that, I need to get rid of the log base 4, which I use its inverse, which is 4. Careful. This is not 4x. It's 4 to the x power. If you write 4x, you're going to get points off. Okay? You're exponentiating. You're making it an exponent. You have to do that. That's not an option on that. Keep rolling here. Keep using our inverses and our rules. Here, sort of similar to what we had there. Now, reminders. Inverses. ln and e. A log of a base number and its base. In other words, I need to get rid of 5. That's not 5x. I can't divide by 5. Instead, I'm going to use the log of base 5. Because that will make those cancel. But now what, Mr. H? Do I just get to leave it like that? No. I actually want the decimal. Well, how do I do that? Remember, it's a change of base. It's always going to be the log of my value, of my a value, 16, divided by the log of my base, the 5. And I have to remember to close that first parenthesis. That's the key. As long as I remember that first one, I'm good to go. And typically on these, we've been going to 3 decimal places, I believe, so we will keep right on doing that. Same idea going here. If I use log base 5 to get rid of 5, to get rid of log base 5, I just use 5. Even to the other side where there's no log, because it's still an equation and I still have to do to one side what I do to both. 5 to the 4th, which is 625. Again, it's an exponent. Here, I want to isolate 8x. I have ln there. Use its inverse, e. Don't punch e to the 4th into your calculator yet. Don't do that stuff until the end because you'll end up rounding twice and your answer is going to be off. Now, e, again, every calculator is different, but on a lot of them, it's going to be the inverse of ln. They're the opposite. So second in ln, close parenthesis. So 6.825 right there. Okay. Next one's finally where we get to start doing something a little more interesting. Here, the bases aren't the same. Okay, can't do that. Here, though, can I take 16 and turn it into 4 to something so my bases are equal? I sure can. I can make it 4 squared. Now that those 4s are the same, we talked about this before. Once my bases are alike, I can basically cancel those out, multiply my exponents on each side, and now it becomes an Algebra 1 problem. But I have to have those same bases. I may have to change one, I may have to change them both. And I just work my way through. And again, if you're watching this later, a good strategy always is, if you're not sure on something, hit play on that question until I get to a part that you think you get, and then pause me, try to do it yourself, then you can go back and see if you did it right after that. Use these as a study tool. Here, now I look at the log, I'm like, ooh, I'm going to log right away. Get that 2 out of there. And this, again, is where you have to make an assumption that we remember certain things. Okay, this log's base 10 if I don't see a number here. So I'm going to use the 10 to exponentiate it. I do need to know, well, in a minute I do. I'm going to leave this for a second. I don't want to round until I absolutely have to. Add my 44 over, which does not get added like to this. It doesn't make it 54 or some crazy thing like that. And the reason I waited is now I can punch this in at one time, and I'm not going to have to worry about rounding stuff. So like I could do 10 to the 1.5, and then just add the 44 right away, and I'm not going to do it and then round again and round again. I do it once and I get the answer. If my logs on both sides are the same, sweet. Exponentiate, goodbye logs. We wish we had 10 of these coming on the test, because everything else just stays there. Divide by 2. Woo woo. Good to go. So again, don't make this trickier than it needs to be. Here, before I can deal with e to help my ln, I got to get the 1 out of there. I got to deal with that -2. I just keep chipping away at the stuff on the outside until I get to the part that I want, which is getting to that natural log next to x, because again, now I can just use its inverse, e. So we got to figure out what e to the 2.5 is here. Again, e is second ln, at least on the calculators we have in here. Get my answer there. And then I'm ready to go into story problem mode. Now again, just like they are on here, you'll be given the formula to use, okay? So the population of a city in 1985 was 1,275,390. Okay. Population was growing, plus, at a rate of 4% per decade. Predict the population of the city in the year 2005. Decade is a 10-year period. So 1985 to 2005 is 20 years. Divided into 10-year periods means there's 2. And if some of you want to punch those in on the calculator, you can, but you're going to get an e value that you have to make an adjustment on, because nobody goes around saying we have, 1.2 times 10 to the third people. That just, we don't do that. So when you can, I would just go ahead and type it in like this and get my people. Just to quickly show you what would happen if I typed it in the calculator part. And if I did this, instead of using 2 for my exponent, I'd use x. And if I went to 2 on this one, this 1.38 e to the 6 means I'd do 1.38. And then I'd move the decimal point 6 places to the right. There's rounding issues here, but it's okay. But I don't want you writing 1.38 E6, because half of you wouldn't even know what that meant if I pulled you up and said, what does that mean? You say, oh, no, it's what the calculator said. Value of a new car purchased for $18,500 decreases, minus, by 8% per year. What's the value after 4 years? Again, if you don't have to get fancy with the y equals part? Don't. Just type in, and you always get numbers that you can actually use for answers. So that car after 4 years is worth a little over $13,000. Now, how many years until the car is worth $10,000? Now we have an application to put in here, because we don't know how many years, and we need to find that out. So instead of going to guess and check, now I can use the chart. 10,000. 8 years. Or if you wrote 7 to 8 years, because it happens somewhere in here between these two, that'd be okay too. I'd have no issue with you doing that. We're just bombing along here. All right, we deposit money in our account that pays interest compounded continuously. Notice no end value. We use E when it says continuously. How long till the balance triples? Well, it didn't tell me how much money I had. I'm going to make something up. I'm going to say I had $100. They tell me the rate. I don't know the time. Triples means I have 3 times as much. So I chose to start with 100. So I'm going to be looking for when y equals 300, but this is what goes in the y equals part of the calculator. So I'll do my 100 E, my second ln, to the 0.035x, close it. How long until it triples? How long until I get to $300? It's not going to take too long here. There we go. 32 years. If you said 31 to 32, that'd be okay. Now, this one I don't have to do anything with the calculator. The growth of a stock's value after its purchase in 85 can be represented by the equation A equals 500 1.04t. What was the value of the stock in 1985? Okay, this is always my initial value. So $500. The rate is 1 plus or minus my rate. Well, there's the 1, so my rate is 0.04. But this is always as a percent. So it's 4%. So that's what happens when you actually get one set up for you ahead of time. Okay, more investing. Okay, invest $8,500 in an account, okay. Paying 4.5% interest, make sure it's 0.045. 0.45, I'd love it's 45%, but that's not realistic. Compounded monthly end value, it's 12. Find the account balance after 10 years. Notice I have numbers for everything. I don't need to get cute. Again, I could, but who wants to do that? So I'm going to type in everything I see, just the way I see it, including the fact that I'm going to have parentheses around my exponent. 'Cause if I don't, this isn't going to work. Find the account balance after 10 years. Okay, let me go back here. Wait a minute. Oops. Never hit enter here. I hit that instead. That's better. As they all chuckle and laugh. Hopefully not in front of me. And I get my value right away. I don't have to go searching for it. But then I look at the next question. How many years will it take for an account to double its value if it collects 5% interest compounded quarterly? I'm using the same thing. Again, they're not telling me how much. I always like using 100 when that happens. Collects 5% quarterly. Happens 4 times a year. And how many years? So I don't know what this value is. But I know double means 2 times. So this would be 200. But that's the part I'm plugging in my calculator. And again, I got to go to the fancy part this time. Make sure when you go to your exponent that, again, that you have the parentheses. Probably on both sides would be wise. Yes. So how long until I get to, oh, how convenient, till I get to 200? 14 years. Again, if you wrote 13 to 14, that's okay. Then the problems that we always have the most fun with. You have money in two different bank accounts, and they give me equations for both of them. How long will it take for the two to have the same balance? Okay, we're going to do an application, and I know some of you are going to scream and yell, we didn't do this exact thing. We did something similar with the last quiz and kind of spoke about it afterwards, so no complaining. So I'm going to put both of these in the calculator at the same time. Just making sure I get everything in right. Okay, double check. Looks good. Now here's what I want you to notice. When I bring up the chart, let me get back to 0. Okay, which one's bigger at the start? Account 1 is, right? So here's what I've got to figure out. When does account B, or Y2 on my calculator there, overtake A? So I start looking down, and I get down here to 6, and I'm like, nope, 8. First one's still bigger. Still bigger, still bigger. Oh, they're getting close, though. There. When I get to year 12, I notice that now my second column has a greater value than my first. So what that tells me is it's going to take about 12 years until they end up having the same balance, or you could say 11 to 12 if you want to, because it's really going to happen somewhere in the middle here. So which one's the better long-term investment? Well, shoot, the one that's going to give me more money long-term. Because as I keep going down, this is going to keep getting further and further and further away. I mean, now 20 years is almost $1,000 better. So B is greater over the long term because it asks for a long-term investment. The values go up more. But the key is, when does the one account overtake the other? That's when they'd have approximately the same balance. We're almost there. Oh, another story problem? Sheesh. Okay, we got Busy Bee and we got Bugsy. Guess what? They're giving me expressions to work with again. Let's punch them in and do some comparison shopping here. And, oh, wrong button. Find us a good job. All right, 1,800 x plus 60,000. And the other one's starting me at 50,000 with an 8% raise each year. Ooh, I'd love to get an 8% raise each year. There we go. Okay. So now let's do the comparison again. Go back up to the start. Okay, at the start, the first one, Busy Bee, looks like it would be the best. But when I get down here to year 4, I notice the second column's already bigger. If I look a little further, wow, the second column's a lot more. Sign me up. So which one's better? To me, Bugsy, the second one, is better. Because after 4 years, you make more money. Now, maybe if you tell me that you're only going to stay at this job for a couple of years anywhere because it's just a stepping stone. Well, then maybe Bugsy's better. But you have, Busby, excuse me. But you have to explain that then. But to me, the one that gets bigger over a long period of time is the one I'd rather have. Oh, how many years later? I was talking about that, now I forgot. It took us how many years till the second column overtook the first? Year 4. Year 4 is when it actually changes. So that comes in handy with your answer too. All right, down the home stretch. What's the solution of the equation? Bases need to be the same. If you don't know off the top of your head, play with them. Maybe some of you can go down to 2 to some power. That would actually work on this one. Once the bases are the same, we tell them adios. Multiply the exponents together, and now I'm just doing an Algebra 1 problem. And get my answer. What's the asymptote? There's a shift of down 2. I could type this in my calculator, but I already know it's 0 unless there's an up or down shift. Use it. Take advantage of it. But if you want to look at the picture, you can. You could just type that in your calculator. Which of the following is equivalent? What does divide become? Divide becomes subtract. 2x minus 3. Winner, winner. Oops, I didn't put my letter in this last one. What's the value of this one? X equals 0. What's anything to the 0 power equal? 1. Negative 3 times 1 is negative 3. I'm just seeing if you pay attention to basics. What are the solutions? Well, let's get these on the same side. Oh, guys, gonna make us factor. Hardy, why? Why? Okay, that x gets set equal to 0. You're like, well, how am I supposed to figure this out? What to the 4th power equals 256? When in doubt, 4 to the 3rd? No. 4 to the 4th? Hey. Oh yeah, with that bigger exponent, it's plus or minus on this stuff. I gotta remember that. 0 plus or minus 4. Oh yeah. Oh, I almost boneheaded. How many answers are there going to be? No, same as the biggest number of exponents. What a bonehead. I didn't even have to do all this work. How many answers are here? 4. That's not right. How many answers are here? 3. That's not right. How many answers are here? 1, 2, 3, 4, 5. Oh, 5. I think this is right. 1, 2, 3. No, that's not right. Just look at this. Biggest exponent tells you how many answers. Don't make life difficult like I just made for myself. Oh, factoring. Oh, Hardy. Why? What do I cube to get x cubed? X. What do I cube to get 27? 3. It's not B. It's not C. How do I do the rest of this again? Oh, it's that crazy pattern. Square the first term. Change the sign. Multiply x and 3 together. Square the last term. Even if you weren't sure, once you see plus and then minus, those are both minus. If you absolutely aren't sure, you could multiply this out with a box. If you guess wrong, though, it could take you a while. Okay, this is it. It took us a little over 37, 38 minutes here with me yammering a whole lot. So you got to be ready. It's going to be a little bit shorter than this, but I just want you to be ready to go. Note, there are only 32 minutes on this, 32 minutes, thinking about the time that you're hearing, 32 questions on the test. So again, it's not as long as the review. We got done in about 37 minutes. The test itself is about 2/3 this size. So you'll have plenty of time. Just be ready, look things over. I'm sure you'll do great.